Hello guys, we are back with our next lecture. In this lecture, let us continue with the next flip-flop. That is a JK flip-flop, guys. Guys, this videos like JK flip-flop, T flip-flop and D flip-flop will be a bit faster because you know the exact structure like how and what we'll be discussing. So it will be a bit faster, guys. Okay. Yes. Okay. Coming to JK flip-flop. Okay. So JK, right? Yes. So that block diagram will be simple. J and K clock. Q and Q bar, right? Yes. So if you recall, I told one thing. So always what we study, it will be represented in reverse order in implementation. So that is the reason why K will be on the top and J will be at the bottom. Okay, so I think most of you have already observed the change in the diagram. Did you observe it? I think most of you did. So the only change here is so the input just assume this line is not there, guys. At that time it looks exactly like SR flip-flop, right? SR flip-flop, right? Yes. So the only change between SR flip-flop and JK flip-flop is you will add this line extra. So the input, the output is given as input to this K also. Got it? To the AND gate also. Got it? Yes. So that is the only simple change, guys. Okay. I'm getting a small doubt like this should be connected to this or this. I'll be just cross-checking it. I'll be coming back in a minute, guys. Just give me a second. Okay, I have just cross-checked the diagram, guys. The diagram is correct. So this output will come as an input to this AND gate. Okay. Yes. Okay. So based on the appearance, it looks more like SR flip-flop, right? Yes. The behavior is also almost the same, guys. So if you want, you can test it, guys. So in the latches video, I have clearly explained how to test this, right? By giving inputs from here. So basically the input is given here. This is a Q. And this is a Q bar, guys. So the input is given here and it will pass in all the different directions and you will generate the outputs, guys. So if you generate, you will get whenever J and K, both of them are 0, it acts as a storage, guys. So whatever you give is stored in Qn, that is only what we get in Qn plus 1. Okay. Coming to the next case. So whenever K is 1, okay. So if you recall, this is a set and this is a reset, right? Based on the previous observation. Yes. So whenever this reset or K is a 1, it is going to make it 0. Similarly, whenever the set or J is a 1, it will make it to 1. Okay. When previously, when both of them are 1, we used to get invalid cases. But here, if you solve it, you will get 1 and 0. So basically, it is nothing but complement of Qn, right? Yes. So here we have covered all the 4 cases, guys. Got it? So Qn, 0, 1 and Qn bar. Got it? Yes. So this is JK flip-flop, guys. Okay. So for this, I think now you can draw the K-map and you can find the equation, right? Characteristic equation. So if you draw the K-map, it will look in this way. Okay, so you will get two literal, two variables. So 4 literals in total. Okay, so Qn plus 1 is equals to JQn bar plus K bar Qn. Okay, so you will be saying that, okay, so please give us a trick. Last time you gave SRI and we remembered it, right? Yes. So for now, for JK, you can remember in this way. So I think everyone know the name Jack, right? JACK. Okay, yes. So take the first letter and the last letter. Okay, and give add, and for the second one you give bar, for the first one you give bar, Qn. Wherever bar is there, for only one term it will be there. So that's the remembering trick, guys. So this is how I remember for JK flip-flop. Got it? Yes. Okay, using the same concept like previous, you can fill the functional table by observing the truth table, guys. I think both of them will not be visible in the same page. Okay. Yes. So whenever J is 0, J and K both are zeros, it works as a memory. J and K are zeros, it works as memory. 0 1 it resets it. When 1 0 it sets it. At 1 1 it works as a reverse, like that's nothing but a complement of Qn, right? Yes. So coming to excitation table, it will look in this way. Okay, yes. So based on the function table, you can draw the state diagram, right? So when Q equal to 0 and Q equal to 1, based on the things, it will swap in between themselves. Got it? Yes. So this is a simple explanation for JK flip-flop, guys. Okay. Yes. So you might be saying now that, okay, so when I told for SR flip-flop, the reason for introduction of JK flip-flop is I told that one row is giving invalid and it's going to raise some issues, right? Yes. So now you will be saying that I told there are 2 more things, right? Like T flip-flop and D flip-flop. So now you will be saying like why T and D flip-flop when this is working absolutely perfect? Because It is a small flip-flop with 2 inputs. It is giving 4 different outputs, right? Sorry, with 3 inputs. Okay, so qn 0, 1 and qn bar, right? Yes. So now the issue with this JK flip-flop is it is overpowered, guys. It is doing everything. So is it needed? When we want to store something, we just need the memory concept. If we want to complement it, we need only complement concept, but it is doing everything. So this is a disadvantage, naming that it introduced other 2 flip-flops, guys. Okay, yes. So now I hope you got the reason, right? So why exactly we'll be studying the next flip-flop. Okay, yes. So the next flip-flop is a T flip-flop, guys. Okay, yes. So I hope everyone got some basic idea, right? Yes. So in the next lecture, let us continue with the T flip-flop. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.